Have you ever wondered if there could be life on other planets in our solar system? As we cast our gaze upon the cosmos, we are continually fascinated by the thought of extraterrestrial life. Decades of astrobiological research have led us to consider not just planets, but moons and even dwarf planets as potential habitats. From the red dunes of Mars, once warmer and wetter, to the icy shell of Europa, Jupiter's moon, which hides a subsurface ocean, each celestial body presents a unique set of conditions and possibilities. We look at Saturn's moon Enceladus with its geysers of water vapor and ice, and Titan where lakes of liquid methane and ethane pose the question of exotic life forms. Even Venus, with its harsh surface conditions, and the asteroid Ceres, offer intriguing prospects. As we journey through our solar system, let's keep an open mind to the extraordinary possibilities that await. Our first stop is Mars, our neighboring planet that has intrigued scientists for decades. This red planet has been a beacon of curiosity, with evidence suggesting that it was once a warm, wet world with rivers, lakes, and possibly even vast oceans. Today, water on Mars mainly exists as ice or vapor, yet tantalizing clues point to the presence of liquid water hidden beneath the surface. Now, imagine a life form that can survive in such conditions. On Earth, we call these organisms extremophiles. These hardy creatures thrive in environments once thought inhospitable, from the scorching heat of volcanic vents to the icy depths of Antarctica. The existence of these extremophiles raises an intriguing possibility. Could similar creatures inhabit the subterranean aquifers of Mars? Could these conditions have fostered life? The search continues. As we delve deeper into the mysteries of Mars, we inch closer to answering one of humanity's greatest questions: are we alone in the universe? Moving further away from the sun, we find two icy moons with hidden secrets beneath their surfaces. Europa and Enceladus, moons of Jupiter and Saturn respectively, are cold and desolate on the surface. But don't let their icy exteriors fool you. These moons are hiding deep, subsurface oceans that could potentially harbor life. Let's first venture to Europa, one of Jupiter's largest moons. Beneath its frosty crust lies a vast ocean, kept warm by the tidal heating generated by Jupiter's intense gravitational pull. This tidal heating prevents the ocean from freezing solid, despite the moon's distance from the sun. But what's truly fascinating is that this ocean could be twice the volume of all Earth's oceans combined. Imagine that. Now, where there's water, there's the potential for life. And Europa's underwater world might just be the place to find it. The ocean could be teeming with microbes, similar to those found around hydrothermal vents on Earth's ocean floor. The heat from these vents can provide the necessary energy for life to thrive, making them underwater oases in an otherwise harsh environment. Shifting our gaze to Saturn, we find Enceladus, another icy moon with a hidden ocean. This small moon is one of the most reflective bodies in the solar system, bouncing back nearly all sunlight that reaches it. But the real magic happens beneath its icy shell. Geysers of water vapor and ice particles erupt from cracks in the surface, hinting at the presence of a subsurface ocean. These geysers are not just spectacular sights, they could be signs of hydrothermal activity, similar to what we see on Earth. And just like on Europa, these vents could provide the energy and nutrients needed for microbial life to exist. These icy moons may be far from the sun, but they harbor potential for life in their hidden oceans. As we continue to explore our cosmic neighborhood, we might find that life is not exclusive to our blue planet. And who knows? The first extraterrestrial life we discover might just be living beneath the icy surfaces of Europa and Enceladus. Not all potential habitats for life are as we might expect them. Let's travel to Saturn's largest moon, Titan, a world that redefines our understanding of what could be a habitat for life. Blanketed by a thick, nitrogen-rich atmosphere, Titan is a frigid world where water exists as hard as rock, and rivers and lakes are filled not with water, but with liquid methane and ethane. Now, these conditions might seem inhospitable to us, but they could potentially support an exotic form of life unlike anything we know on Earth. Imagine life forms that use methane as a solvent, much like how Earth's life uses water. These methane-based organisms, if they exist, could thrive in Titan's hydrocarbon-rich lakes, or even in its subsurface oceans. While this is still a topic of ongoing research and debate, the thought itself is exciting and opens up new possibilities in our quest to find extraterrestrial life. Now let's turn our gaze toward Venus, a planet often deemed inhospitable due to its scorching surface temperatures and corrosive atmosphere. However, this narrative is shifting as some scientists are looking upwards, beyond the planet's surface, into its clouds. You see, the cloud layers of Venus, about 30 to 40 miles above the surface, experience milder conditions with temperatures and pressures similar to Earth's surface. The intriguing proposition here is the possibility of microbial life existing in these milder cloud regions. These microbes, if present, could be using sulfur in the Venusian atmosphere, much like how some Earth-based microbes use water. This is a radical idea, yet one that has sparked renewed interest in Venus and led to proposals for future missions to explore these cloud habitats more closely. In the search for life, sometimes we must look beyond what we consider normal. Whether it's in the methane lakes of Titan or the cloud tops of Venus, life may be lurking in the most unexpected corners of our solar system. It's these unconventional habitats that remind us just how diverse and surprising our universe can be. Our search for potential life doesn't stop at the familiar planets and their moons. Let's voyage to the outliers in our solar system: Ceres, Ganymede, Callisto, and Triton. Each of these celestial bodies has unique features that could potentially harbor life, at least in its most basic form. Starting with Ceres, the largest object in the asteroid belt between Mars and Jupiter. Recent discoveries have unveiled a rather surprising feature: water ice beneath its surface and possibly even a subsurface ocean. Just like Earth, life on Ceres could exist in these subsurface water reservoirs. Next we fly over to Ganymede, Jupiter's largest moon and the largest moon in our solar system. Beneath its icy exterior, Ganymede harbors an ocean, sandwiched between layers of ice. This vast body of water, kept liquid by Jupiter's gravitational pull, could provide the perfect environment for microbial life, much like Europa and Enceladus. Then there's Callisto, another of Jupiter's moons with a hidden secret. Beneath its icy surface lies another subsurface ocean. Although Callisto doesn't experience the same tidal heating that its sibling moon Europa does, it still holds potential as a habitat for life. Its ocean, combined with the right cocktail of chemical compounds, could make it a cradle for microbial life. Finally, we reach Triton, Neptune's largest moon. Unlike most moons in our solar system, Triton boasts a substantial atmosphere and a surface covered in nitrogen ice. Beneath this icy exterior, there's potential for a subsurface ocean or active geysers, both of which could offer the necessary conditions for life to thrive. As we explore these outliers, we're reminded of the remarkable resilience of life. In the harshest environments, against the most severe odds, life as we know it, or perhaps in forms we've yet to discover, might find a way to exist. Even in the most unexpected places, life might find a way. Finally, we reach the outskirts of our solar system, where two small bodies have captured our attention. Nestled in the frosty reaches of space, Pluto and Charon, its largest moon, refuse to be overlooked. Despite their size, they're brimming with complex characteristics that have sparked profound interest. Beneath Pluto's icy exterior, there's compelling evidence of a subsurface ocean. This ocean, a reservoir of potential, could harbor the ingredients necessary for life as we know it. Meanwhile, Charon, though it may seem a frozen wasteland, carries traces of a past filled with liquid intrigue. Some scientists believe that it too once cradled an ocean beneath its surface. These distant bodies, far from being desolate and lifeless, are subjects of intense interest for future exploration. They hold secrets that are yet to be unraveled, mysteries that could reshape our understanding of life's reach in the universe. Though distant and small, Pluto and Charon remind us that potential for life can exist in the most surprising places. Our journey through the solar system has taken us to some extraordinary places. We've traversed the red plains of Mars, speculated about the possibility of life thriving beneath its icy surface, and marveled at the potential of Jupiter's moon, Europa, with its subsurface ocean. We've plunged into the depths of Enceladus's geysers, considered the potential of Titan's hydrocarbon-rich atmosphere, and even dared to dream about life in the clouds of Venus. We've journeyed to the asteroid belt to visit Ceres, and to the distant moons of Jupiter, Ganymede, and Callisto. We've even ventured to the outer reaches of our solar system, exploring the enigmatic moons of Neptune and the complex duo of Pluto and Charon. The universe is vast, and we've only just begun to explore its potential for life. Who knows what future discoveries will reveal? Thank you for joining us on this journey, and if you enjoyed this cosmic exploration, please subscribe to our channel for more fascinating insights